Okay, guys, in this video lesson, we're going to take it to the next level when we deal with these different circuits and talk about what happens when you have a series circuit and a parallel circuit and they're both there at the same time, okay? So to do that, we want to talk about this idea of when we combine the two together, we got to start thinking of a circuit within a circuit, okay? And very much like orders of operations in your math world, that you just need to do certain things first, get them accomplished that will allow you to solve for things later on, all right? Now, before you can move any further any more than that, we have to be able to identify the type of circuit we're dealing with, okay? There are two main types of network circuits. You have a parallel paths that are in a series circuit, or you have a series path that's in a parallel circuit. So we often call these parallel in series or series in parallel for short, okay? Now, the way you identify a parallel inside of a series circuit is you look for where the first resistor is or the first device is. Now, in this particular example, we have our battery here, and the first resistor, it is going to have all of the voltage and all of the current flow directly through it. So there's no other alternate route. It's a single path back to the battery, okay? Which means that all of the current has to flow through this resistor, making this a series circuit, okay? Then it splits into two different pathways. So we do have two pathways, but these two pathways come after a single path resistor, which means this is a parallel. Right here's parallel. In series, here's the thing in series. Okay. Now, the other option here is we have your battery, and when you come to your first resistor, whether it be this one, or this one, no matter which way we look at this, when we come to our first resistor, it's after the split. So we come around and we first split. We come down here and we first split. So on either side of the battery, same thing can be here. This could be on that side. On either side of the battery, the first thing we come to is a split. So that means overall we have a parallel circuit here. But inside of that parallel, we have a series. So we call this a series in parallel. All right. The way I visually look at it is I always look for, is there a resistor that causes all the electrons to flow through it? If that's the case, I know I have overall series. Or is the first thing I see is a split, then I know I have overall parallel series, okay? Now, for us to work through this, we want to think about orders of operations. We're going to solve for the internal resistances first. So I'm going to tackle the R2 and R3 first if I have a problem like this. I'm going to tackle R1, R2 if I have a problem like this. Once I know these, I can combine them and then to treat them like a single resistor once I know their total, and then I can combine it to R3. Same thing over here. Or once I know the resistance of these two together, I can treat them like one resistor and then combine it back to R1. So kind of like inside the parentheses first and then solve outside the parentheses like you would in math. So here's our process, all right? So here we go. We have our circuit here, and we've already identified this, that it is a parallel and series circuit, okay? So we have a parallel setup inside, which is the main thing here is a series circuit. So I'm going to first solve for the resistance inside of this circuit. So I'm going to find out what is the resistance of R2 and R3 together. I'm going to generate one number from them, all right? So to do that, I'm going to use my equation for a parallel circuit. This is what makes it hard, is I had to make sure I use the right equation for the right type of circuit. So because these are in parallel, I'm going to use the equation for parallel circuit. I'm going to solve for my resistance total here. And once I know that, that now becomes my value to work back into R1 for that overall resistance. So what I can do is I can take my total here, plug it back into how a series circuit would solve it. So first I'm solving the parallel side, then the series side. And I can find my resistance total between the two things, okay? Once we know the total resistance, if we know the total voltage of our battery, then that allows us to start solving for the current flow inside of here, okay? So this extends into looking for currents and that kind of stuff also. If we flip the scenario and we look at this one, we now have a series inside of parallel. So in this case, I'm going to solve for R1 and R2 together first and combine them into a single number, okay? So I'm going to say that the R1 plus the R2, because this is a series, I'm going to use that equation and get to my total there. And then using that total, I'm going to apply that back to a parallel circuit where my R total gets placed in here in relationship to my R3 to find my resistance total for my parallel circuit. Okay, so it becomes a two-step process as we work through these. Okay, as you find your resistances. Now, again, this is only one step of the process. So we're showing you how to find the different resistances because you need them to be able to find current and to be able to work back through voltage. All right. So let's go through a practice problem. So in this problem here, we want to find the total resistance of our system. Okay. Let's first take a look at what we have. Well, here's our battery, and the battery is running. Electrons run through here. They turn the corner, and they hit this. So they hit a single resistor, and all the electrons are forced to flow through this resistor, come up, and then it splits off. So I have a parallel portion inside my series circuit. So this is a parallel in series, all right? So mathematically, we're going to solve for the parallel part first, find out the resistance there, and then we're going to add it to the resistance down here, okay? So pause the video, solve this, and then we'll go through the solution. All right, here we go. So first of all, the parallel part. So I know that the resistance of the parallel portion, I'm going to use R sub P now, so it reminds me this is the parallel part, is R1 and R2 together. So it's 3,000 ohms, 10,000 ohms, reciprocals of those, do the reciprocal of that, and I should get 2,308 ohms. Okay, that's just for these two resistors. Once I know that, I can then bring it down into the series part of my circuit, and my 2,308 ohms plus the 5,000 ohms gives me 7,308 ohms. Okay, this part we just add R plus R because we're in series. When we do parallel, it's reciprocals. That's why it's important to know when is it parallel, when is it series to do this. We now know the total resistance of this circuit. Okay, so the next step would be let's find voltage and current. All right, now current is the next question in our list. We're going to skip it for now. And the reason why is because I would rather find the voltage first. It's more important for me to find this first. It's more useful because once I know the voltage at every area, it's going to be pretty quick for me to find the current, okay? It's a more efficient way to solve this, all right? The reason why we didn't format it that way is because the practice problems before we went in this sequence, but now we're going to go this way instead, okay? So now let's take a look at what we have. We know that our total resistance is 7,308, okay? We know our total voltage drop is 9 volts. So if I have my total volts and I have my total resistance, I should be able to find my total current, okay? It might seem counterintuitive. I just told you we're not solving for current, but we need the total current because if I know the total current and I know the resistance of this resistor, I'm able to then find the voltage drop at R3. Once I know the voltage drop at R3, I can just subtract it from 9 to find the voltage drop over R1 and R2, okay? So I'm not sure if that makes perfect sense or not, so give it a shot. Try to solve it. If you get lost in it and you can't solve it, then unpause the video and take a look at how I solved it, okay? But give it a shot first. All right, here we go. So first thing we did is said, okay, my total voltage is my current times my total resistance. So I changed it over to find current. So I have my 9 volts over my 7,308 ohms, and the current flowing across the circuit total is 0.00123 amps. So as this thing moves down here, we get 0.00123 amps, and it crosses this circuit. Because it's a single in series, this resistor has to have that much current flow, okay? So the 5,000 ohm resistor has to have all of these current because it is in series, which means I now can use the same equation to find the voltage just at R3. So the voltage drop here is going to be my total current because it has to all pass through this resistor. It's not branched yet. Times my resistance, I get 6.16 volts. So of the 9 volts, 6.16 get used in this resistor. Now, the remaining voltage comes here, comes up here, and because it splits, each electron can either pass over this resistor or that resistor. Because they don't have to cross both of them, they can pick one or the other, the rest of the voltage gets dropped in either one of these. So we're going to solve for them both at the same time. Okay, so voltage at 1 and 2, because we're now part of a parallel circuit, will be equal to each other. Well, the total voltage was 9. R3 took up this much, so what's left over is 2.84. So now 2.84 volts will be dropped here, 2.84 volts will be dropped here as an electron passes through them. For me, it's best to visualize one electron. So one electron has 9 volts. It has to cross this. So it now has used up 6.16 volts. It now has 2.84. It comes to here. It goes down this pathway. It uses its 2.84. It's now at 0, back to the battery. His buddy goes here, loses 6.16. Instead of going down that pathway, it goes up here. It also has 2.84 left, so it can dump 2.84 volts here and back to the battery. That's why they both can be 2.84 volts here, okay? Because they can choose which path they go under, all right? Once we know the voltage, now it's much easier for us to find the current because we know the resistance and the voltage at every position. We know them both, we can just use Ohm's law, okay? So go ahead, pause the video again, and see if you can find the current now through each one of these resistors as we finish up here, okay? All right, here we go. So now we have our voltage again, remind us of that. We already knew the current going through R3 because through R3 that was our total, so that one we already knew. The only thing new is I have my 2.84 volts going over R2, my 2.84 volts going over R1. We're going to divide by the resistance of each one, so divide by 10,000, we're going to divide by 3,000, and we're going to get the individual current flow for each one of these circuits, okay? This is a long process. This is a lot of math to do, and it's a lot of thinking, okay? So take your time as you go through these problems and process what is parallel, what is series, which equation am I using, and the right way to use it, okay? There's additional practice for this in your student files you can also use to give you more practice. Also, we have additional practice for this in your homework, all right, guys? That is it, guys. Thank you.